Welcome back, class. This is section 4-4 in your textbook, Proving Triangles Congruent. And previously we had talked about, in order to prove triangles congruent, by the definition of congruent triangles, you had to show that all of their corresponding parts are congruent. So in our example up here, you would have to show that this side and its corresponding side there matches. This side with this side, and that side with that side. But that wasn't enough. You still would have to show the angles are congruent. So that would be this angle congruent to its corresponding angle there, and that angle congruent to that, and this angle congruent to this. So that's a total of 6 pairs of parts, 3 pairs of angles, 3 pairs of sides. So that's a lot of parts to show congruent. Turns out that there is a shortcut to this, that we don't need to have all 3 pairs of sides and angles. Instead, all you really can do is cut that in half, and there's some special shortcuts then that only use 3 pairs of parts total. So instead of all 3 sides and all 3 angles, we're going to find, I'm going to share with you today actually, 3 shortcuts that cut it in half into 3 parts. Now before I can show you that though, you need to understand some terminology, and one of the things I need you to be able to understand is what we would call an included side. So let's say we've got a triangle here, and on this triangle we already know that we've got some angles here and here, and I want to identify what would be considered the included angle, or I'm sorry, included side. So when looking at this, just think of that word included as a fancy way of saying in between. So when I look at my angles here, these 2 in particular, the side that would be considered in between is the side that joins them. It's this side right here. So if I were to label this ABC, side AB is the included side, meaning that it is in between those 2 angles. Okay, we could also have an included angle. So if I make another triangle over here, but if I'm going to talk about an included angle, that means instead of starting with 2 angles already like this one did, we're going to start with 2 sides. For example, what if I knew this side and that side, if I knew their lengths? We'll call this triangle XYZ. And if I wanted to find the included angle, again, that's just a fancy way of saying in between. On this one, the best way to show it to you is to simply erase the side not involved. I've got a single, a double here, and then ignore this one. And do you see the only angle left is this angle right here at X. So angle X is the included angle. Again, it's just a fancy way of saying it's in between the 2 sides. I'm going to draw that back in just to show you then that out of all our options, again, that was the one in between, included. All right, so these 2 ideas come into play on some of our shortcuts today. Now, as I said, our shortcuts are going to cut the number of parts that we need in half. Okay, so our first shortcut you'll see listed on your postulates and theorems for this chapter. It's postulate 4-1. But when you list these for answers on any assignments you do, instead of calling it postulate 4-1, I want you to call it by its name. It's known as the SSS postulate. Okay, the SSS in this stands for side, side, side. Okay, so what they're trying to say then is that actually we don't need to know anything about any angles. All we need is the sides, and we can prove triangles congruent. So if we have a couple of triangles that I want to prove congruent, like these 2 here pictured on the board, if I could show that their corresponding sides, this one and this one match, that one and that one, and finally these last 2 on the bottom, if I could show that, so if all of that's true, then I can show the triangles are congruent. So then I can show that triangle ABC up here is congruent to triangle XYZ. Space that out a little bit. Okay, to show you why that kind of works, I mean, think of this example here. As you can see, I have 3 different sized pencils here that I'm going to use to make into a triangle. So if I attach them at their endpoints like this, do you see I can make a triangle that looks like that? Now that turns out to be the only triangle I can make out of this, because even if I try to switch around my sides, like maybe put this one down here and then this one up here, that's still the same triangle that I just showed you a second ago. All I did really was flip it over. Okay, and if I try to switch, a couple of these other sides, maybe put this one over here and then this one over here, again, that's just the same triangle as I was showing you before. It's just a reflection of it flipped over. So if you have 3 set side lengths and they form a triangle like that, there's only going to be one and only one triangle that you can make out of them. It always comes out the same. So that's why they'll always match. Now, that's one of our shortcuts, SSS. We'll put that over here, and we're going to compile a list over there of different shortcuts. Our next one, you'll see listed on there as postulate 4-2. Here's the difference. It's known as the SAS postulate. Okay, as you can probably figure out, the A now stands for an angle. So what this is saying, instead of knowing, like we just said a minute ago, instead of knowing that all 3 sides match, here we're going to have a pair of sides, a pair of angles, and a pair of sides. And the way it's written is very important, because this angle has to be the included angle. It has to be the angle in between the sides. So if I had a couple of triangles I'm trying to prove congruent like this, we'll call this one ABC, this one XYZ again. And if I had 2 pairs of sides congruent, maybe this side congruent to this one, and maybe this side congruent to that one, now I'd have to have the included angle. Now, I just mentioned that a little bit ago. That just is a fancy way of saying in between. So if I look in between these 2 sides, if I ignore the 3rd side, see, right in between is angle C. Same over here, angle Z is in between those 2 sides. So I'm going to draw that back in. So it turns out if we have them in that order, SAS, with the included angle, then that should be enough to say that the triangles are congruent. Okay, it does have to be the angle in between, though. You cannot put the A out front and spell a bad word. No bad words. If it's not the A in between, if it's not the included angle, this does not work anymore. This shortcut would not work anymore. I could kind of prove it to you, in fact. Let's do one that would spell our bad word if the angle was not in between. If I had, for example, here, I'll just do it over here. Let's say we have these 2 sides, and let's say I have this angle over here. Okay? Can you see that okay? Maybe I'll make that a little bigger. All right, so there's my 2 sides, and let's say I have an angle over here. The included angle would have been over here. See how that's the one that's in between the sides? So that would have been the included angle. This is not then. So this would be if I move the A out front, for example, and spelled a bad word. It's not included. This is not enough information to just make one triangle out of, and only one triangle, because I could take this same information and I can make a different triangle out of it. Imagine this. See this side over here that I did not mark? it can be any length you like. So if I were to extend this out far enough, and then if I were to take this side and swing it out like this, I could keep it the same length as it was, what it was down here. I'm just swinging it out till it hits that line again. And do you see it makes a bigger triangle out of that one? You know, I have the smaller triangle here, but when I swing that out further, now it fills the whole thing, and we got a bigger triangle. Both of them would spell donkey, you know, if you put your A in the front, because you have A-S-S and A-S-S, the bigger triangle being different than the smaller. So that's why there is no shortcut that spells donkey, only S-A-S. All right, now there's one more shortcut here that we're going to cover in this section. And our last shortcut is postulate 4-3, otherwise known as ASA. And this time, again, the spelling is important here because the S is in between. So it has to be the included side that we're using here. So if I have a couple of triangles that I'm trying to prove congruent and I want to use this shortcut, I would have to show that I have two pairs of matching angles. So maybe that angle matches that angle and this angle matches that angle. And I have to have the included side, the one that's in between those angles. So when I look at this, the side in between these two angles is the one that joins them. So it'd be that side right there. Same over here. The one that joins them is that side. So if you have that information like that, that's what we call ASA, and you can prove triangles congruent by that. So that's our third shortcut on our list. And we'll add to that list throughout this chapter yet. So there'll be more shortcuts, but for right now, that's the three we want to work with. All right, so let's try some problems based on these so that you'll be able to do your homework assignment that's going to be based on this lesson. Okay, on some of the problems, they're just going to simply ask you, by what method can you prove the triangle is congruent, if any? Okay, so problems like these are going to have a picture that's already marked up with some congruent parts. So you might have a problem that looks like this, for example, where you have this side congruent to this, and maybe that angle congruent to that, this angle congruent to this one. Okay, so when you do a problem like this, the best thing I think to do is try to focus on one triangle at a time here. So maybe, ignore this triangle, look at that one. And when you focus on one triangle at a time, look at what kind of parts you have. I can see in this one I have a couple of angles. So I got a couple of A's in this. And then I do have the side right in between joining them. See that? So I do have the included side. So if you look at this triangle, you have the same thing, two angles, the included side. So we could actually say that those two triangles are in fact congruent by our shortcut ASA. All right, so here's another example. In this one, let's say we know that this side is congruent to this and that side congruent to that, and let's say that's all they give us. Now, normally these shortcuts require three parts: SSS, SAS, ASA. Okay, in this one right now, all I have marked up here at least is an S and another S. So if I am going to prove these congruent, I'm going to need another pair of parts, and I don't know right now, it might be SSS or SAS. Both of those require two S's already. So let's see what we can mark congruent yet. So in a problem like this is kind of special. You need to keep an eye out for this. If you see that the two triangles are sharing a side, See this side down the middle? That side has to be congruent for both triangles, right? I mean, if they're literally, this triangle and that triangle are sharing it, there's no way that side can be extra longer for one of them than the other. So it's always going to be the same length for both. So we actually can mark it congruent even though they didn't for us. And then you can see that that gives us all three sides. So this pair of triangles are congruent by our shortcut of SSS. You may recognize in our 10 commandments of proofs that one of our commandments said to keep an eye out for when triangles share a side. They also told us to watch out for something else, and we'll see if you catch it here in a sec. And yes, we will be doing proofs in this chapter. Okay, so if I look at this next problem, problem number 3 here, let's say I've got a couple of triangles like this. And I know that this matches this, that matches that. Again, that's all they give us, those two pairs of parts. Okay, believe it or not, that's already enough though. I still have to find one more pair of parts, I should say. You know, right now, an S and an S, again, is not enough, just like we had on our last problem. There's still a chance I could prove these congruent though by one of these two methods if I could find one more pair of parts congruent. And when you look at this one, they don't share a side like that one did, but you hopefully notice the cross pattern here that forms an X, and then of course right here at this intersection is a pair of vertical angles. So if we mark those vertical angles congruent in this picture, that gives us an angle that is, by chance, right in between the sides. See it? That side come together to form this angle in the middle. So the angle is the included angle, giving us SAS. It doesn't spell donkey, so that's good. So that is our shortcut we would use on this one to prove those triangles congruent. Okay, let's take a look at this one. Let's try that again. Here's our triangle being split into two more triangles. And let's say those angles are congruent. Okay, on a problem like this, again, there is some other parts that we can mark congruent just by looking at it. Like, for example, if that's a right angle, doesn't that have to be a right angle right beside it? Since they're a linear pair, that adds up to 180. And they share a side down the middle, just like that one problem we did earlier. So if you look up here, on each triangle, I have a couple of angles and a side. The question is that side in between the angles or is it outside? Okay, if you take a look, the one side that would be in between these angles is the one that joins them. That'd be this side down here. And that is not the included side. So, you know, this would be what you would call maybe AAS or something like that. But that's not one of our shortcuts. See that? So we can't use this. Okay, maybe later we might learn one of these shortcuts. Wink, wink. But for right now, you would say something like this is not possible. When we write not possible, all we're saying is that the triangles could still be congruent, we just can't prove it. Okay? But sometimes, you know, there is no way to prove them congruent. You know, if you look at this last example I'm going to show you here, let's say that this angle matches this angle, that angle matches that angle, and this angle matches that angle. Nothing but angles. See that? So if I was to try to come up with a shortcut for this, this would be called AAA. I mean, you have all three angles. But AAA is not one of our shortcuts. You'll see it's not on our list. And there's a reason for it. AAA does not work, okay? You cannot just have matching angles. You might have noticed I even kind of drew the second triangle a little bit smaller. You know, if I was to superimpose this on top of this one, it might look something like this. Where the bigger triangle shrunk down a little bit to be this little bit smaller one. Okay, even though they have matching angles, they do not necessarily have matching sides. So there is a SSS though. If the sides match, then the triangles have to, but there is no AAA. Just to kind of emphasize this idea, to show you what I mean. See this angle right here? Does the measure of that angle change any if I extend the sides out even further? No, right? That's still the same angle. Whether I cut it off here or cut it off back in here, okay, it's still, that angle didn't change any just by extending the sides out. So that's why it's possible to have all the angles match, just like we did here, where all three angles match on the two triangles, but the triangles are not congruent. Instead, they're what we call similar triangles, which we'll study in a later chapter. All right, so that's our examples of how we would use the shortcuts. Our three shortcuts, again, being SSS, SAS, and ASA. One of the other types of problems I want to show you is a problem like this, where they might ask you, what additional information is needed to prove the triangles congruent, and then they'll give you a method, like they might say by SAS. Okay, and then they would have a picture that maybe looks like this. Maybe this is A, B, C, and D. And let's say they already marked on the drawing that these two sides match. Okay, now at first glance when I look at this, I would look for anything else that I can mark congruent that isn't already marked in the picture. So the two things I needed to look out for, if you remember right, was if the triangles share a side and if there are vertical angles. Okay, when I look at this picture, I can see that the two triangles are sharing a side. So that is not something I still need. I already know that's congruent. So I've already got not one, but two pairs of sides. So out of the SAS, I've got the S and the S covered. You see that? I've got those two covered. Okay, so what it's indicating then is that I still need the A, and it has to be the angle in between. So I wouldn't be naming just any angle here. I need the one that's in between those sides. So if I show it by my markings up here, the angles I'm looking for then would be, and I'll use a different color here, would be this angle and that angle. Do you see how those are the angles that are in between those sides? So I'd have SAS, these two sides forming that angle. So in order to accomplish SAS here, the angle I need is angle, now don't just call it angle D, because see how it's different for each triangle. So the first one is the angle D on this side, so it'd be called angle ADB. I need that angle to be congruent to the other angle D over here. That would be called CDB. So that's the only thing on this problem, at least, that I need to prove the triangle is congruent by SAS. I need the angle in between. I need that pair of angles. Let's try one more of those, just to make sure you understand what additional information is needed to prove the triangle is congruent. And this time, Let's do this. And let's do by ASA. And that's all the information I'm going to give you is that right angle indicated right there. Now, of course, if that's a right angle, this has to be a right angle right beside it. And do you see something else that I can mark congruent in the picture? Yeah, you guessed it. They share a side. So see that side DB? It's the same on both triangles, so I could go ahead and mark that congruent as well. That's not something I still need. Okay, so if I look at what I've got so far, I've got a pair of angles and a side. So I've got a pair of angles and a side. Do you see all I still need is the last pair of angles? And it must be the last pair of angles that sandwich in that side, so that side is the included side. So if I'm going to be spelling ASA, it'd be AS, and I hope you see the other angle we need has to be right over here. So ASA. So the side's in between the angles. Same thing on the other triangle, ASA. So again, I need that angle B down there for both triangles. But again, don't just put angle B is congruent to angle B. That is not accurate enough. You need to be a little more specific here. The top angle B would be called ABD. The bottom angle B would be called angle CBD. So that would be the only additional information I need for that last pair of angles. And that way the triangles would be congruent by ASA. That should be enough information for this lesson so far so that you can do your homework, which is the Proving Triangles Congruent worksheet that you should see attached to this lesson.